Hey there, AP Environmental Scientists. Miss Maycutt here from Ballard High School, and we're going to go over personal progress check number 4 from the unit Climate of Hope. This focuses on EK 6.5, fossil fuels, and 6.6, nuclear power. A couple key terms and concepts to focus on are energy conversions, lots of that, nuclear power plants and nuclear reactions, and the impacts of fracking and electricity from coal. We'll start with number 2 and number 6 first, because those gave folks the most trouble. So number 2 asks, which of the following best describes an environmental problem that is linked to the process of fracking? So let's go through them one by one. So A, fracking operations require large tracts of land, which degrade habitat and harm wildlife. Actually, fracking has a relatively small surface footprint. It doesn't require a lot of land. You've got the drilling rig, you've got some gas containers and transport. Can it increase stream flow and water volume? Actually, it's depleting water levels because it's taking the water to pump into the ground. So it will reduce water levels, not increase it. Wastewater from fracking operations is injected into porous rock, which can induce seismic activity. Yes. And it's been in the news and it's crazy and horrifying. So when we have fracking occurring, large amounts of water from underground oil-rich rock is pumping water back underground, and this can trigger an earthquake. Last one, nutrients and phosphorus and nitrogen. There's actually very little, again, surface pollution per se from fracking. That is more from agriculture or wastewater treatment. It threatens groundwater. That's where you have the greatest risk. Next question, number 6. So we're jumping around. At which of the following locations in the nuclear power plant would an accident most likely result in the release of fission products? So focus on fission. We're looking at radioactive material. And if you look at the overall structure of the nuclear power plant, you can see you've got the containment building, steam lines, turbine, transformers, and this giant tower. So, we tend to move from left to right. So if we're going to start here, steam lines, well, if you had steam, energy had to be produced. So make a guess. You're looking for the radioactive material. Make a guess. It's going to be in the containment building where you're containing the highly explosive radioactive material, right? Because A, that's the cooling tower. That's actually where we dissipate and try and heat and try and capture some of the water that was used to cool around the radioactive materials. B, we have the generator. Mechanics, machinery, it is not where we keep uranium. C, the reactor vessel, right? That's here, right, in the containment building. And that is where we're going to have the fission reactions that result in heat production. And the last one they gave was the condenser. And here, this is trailing down here where we might get exhaust from steam, but there's no big fission products. Okay, we're now going to go over the rest of the questions more quickly. So starting with number 1, which of the following describes a step in the generation of electricity using fossil fuels that leads to an environmental problem? So you guys got this one pretty quick. Fossil fuel is burned to boil water. Burning fossil fuel creates carbon dioxide, a greenhouse gas. Yes. Water converted to steam, steam to a turbine, turbine powered generator, all very low impact, mostly just energy conversions that are fairly contained. Next one, number 3, which best describes a potential negative environmental effect of fossil fuel extraction? Well, the first thing you need to focus on is an environmental effect. And A is talking about infrastructure and high startup cost. That's economic. Doesn't matter if it's right or wrong. It's economic. That's not answering the question. Watch out for distractors like that. B, birds are injured or killed. Well, if we're extracting fossil fuel, you're typically digging in the ground in some way, and a bird can fly around it or away from it. They're not going to hit it when they're flying. C, thermal energy produced during the extraction in lakes and streams. Again, that's really focused more on nuclear power than fossil fuel. Air pollutants, methane, particulate matter, definitely. Lots of materials, particulates and toxins coming off from the extraction of fossil fuels. And number 4, a diagram of pressurized water nuclear reactor is shown, and which letter identifies the step where kinetic energy is converted to mechanical. So kinetic, we talk about that as the energy of movement. What's mechanical? Mechanical is doing some form of work. Helps if there's machinery, right? So when you're looking at this diagram, where do you see the machinery? A, we've got the fuel converted to heat, right? You can see the control rods. B, we're using that heat to generate steam. C, there's your turbine, right? So there's your mechanical piece that's going to be turning the mechanical energy. And then D, you've got actually condensation, and it's not releasing, it's reducing the energy in the system. Last one, I had to split over 2 slides because the images are so big and the order's a little different than on your test. I started with the correct answer in terms of defining a nuclear chain reaction. Which of these depicts that? A nuclear chain reaction is when you're converting from one isotope to the next by releasing neutrons. So the neutrons and the protons are in the nucleus. They both are very large, very heavy. They hit the other piece of material, causing more neutrons to be kicked off. And then those neutrons hit another piece, in this case, uranium, and additional neutrons are kicked off, and that causes the chain reaction. In the other slide, we had here a bunch. So here's the chain reaction. In the next one, we had electrons. Electrons are about 1/1000th of the mass and size of a neutron. They don't kick. They're not going to have the impact. They're not an isotope, so that is not what we're looking for. In this one here, we've got one going backwards. That doesn't make sense in an electron. And again, we have an electron and a proton. You change the proton, you change the element. So really focused on the neutrons in nuclear reactions. Neutron, nuclear, okay, help you remember. So that's it. If you have any questions, talk to your teachers. I hope this was helpful. Good luck and enjoy learning AP Environmental Science.